hi, I'm John Haymaker. This is Benjamin Welly over here. Great to be here, and very appropriate that we follow Rob. It's sort of metaphorical because the things we're going to present today around design spaces is, let's see here. Hoping. Oh, that'll help. You plug it into the That's a good sign. And in defense to KP and the organization here, they did tell us to send the presentations in sooner. But there we go. It wasn't tight. Great. Okay, I'm John Haymaker. And really appropriate that we follow Rob and Thornton Tomasetti. You'll see our first slide here. You can see Design Explorer up there on the screen. We're going to really focus in specifically on sort of one set of innovation and disruption in the AEC industry, really around this idea of design spaces. And I'm just curious, if I could see a show of hands, who here before coming today and listening to Rob's presentation was familiar with the idea of a parallel coordinates plot, that diagram with all the lines and things? Who's seen it before or used it in their practice? Interestingly, not so many. We're here to really argue that this is completely transformative in the way that we approach design problems. And we're an architecture firm, so we're sort of following a little bit in the footsteps of Thornton Tomasetti and their experience in data-driven design, and we're really interested in how do we move data-driven design into the architectural practice. So this is Peter Busby, one of our more well-known sustainable designers out of Vancouver, and he's in there exploring a design space. So before I jump into this, I'm going to kind of jump to the punchline, which is why do I think design spaces are so cool? And these are just some of the reasons. I think we find them very useful as a collaborative, integrated mechanism to integrate multiple points of view. They really do provide the framework and the rigor for us to assure that we're having a rigorous design exploration, looking at all the possibilities, finding the very best solution that provides the best value to our client. When we approach design in this way, we feel like we understand the problem much better, so we can really provide guidance and know which are the design decisions which are really driving performance and help us focus in on those. There's a bit of a pushback we often get, particularly as we get into the design world, that by using these tools, by using these methods, we're kind of stifling creativity, we're giving the architects the answer. And we're going to really argue that it's quite the opposite, that by being able to sort of frame the decision in this way, it can actually open up the opportunity for more creativity. We can go to our client and we can tell them, we can maximize your value with confidence. This isn't just a cool design that we came up with. We have the data that can come behind it to really support our decision making. And also, guess what? We're doing less rework. If you kind of come in and frame the problem ahead of time and solve it in this way, you don't have to go back later and fix things. So we introduced the idea of Perkins & Will here. We're founded in 1935 in Chicago, and so perhaps many think we are still headquartered there, but we really are a distributed organization with 25 offices globally around the world with many practice areas and disciplines. I'm the director of research, and about 5 years ago, we talked about the sort of emergence of innovation or research positions within the firm. Perkins & Will reached out to me a little over 5 years ago and brought me on as the director of research. And the process has really been about synthesizing a culture and an organization that can support a robust research organization that can make our projects better. And that's really our focus has been providing more value to the clients, trying to make our projects better for them and for society. So the way we've organized ourselves is around 9 research labs, and you can hopefully read the kind of topic areas there. And they really span a wide range of topics, everywhere from material health, trying to really understand what the materials are that are going into our building and what we know is healthy and what we're not so sure is healthy, and trying to eliminate those, all the way up to things like urban resilience and mobility. And today, we're going to focus in on just 2 areas of innovation that are very related, I think you'll see, for us in the way we've been approaching it. One is our process lab, which is sort of more broadly about how do we apply digital technologies and workflows to our design processes, and energy lab, which is really bringing in a real depth of knowledge around performance-based design and energy, daylight, topics like that. So I'm going to start by just saying design is all about decision making. It's about the questions you ask, and it's the decisions you make. And that's really what really differentiates a good architect from a hack, is how well they're able to come into a problem, formulate their decisions, and then make them efficiently and effectively. And just to kind of give you an example to make this a bit concrete, let's just walk you through a little bit of a case study here. And I'm going to, if you haven't seen enough parallel coordinate plots already, I'm going to kind of build one up for you so you understand really what's going on in these things. So let's just imagine we've been tasked with designing a relocatable classroom for a school client. And our job as architects, I think, is to maximize value for our client. We want to understand what our client wants to achieve, and we want to maximize that value. So we could think about this idea of value as maybe breaking down in terms of subcategories, maybe experience. We want this classroom to have great views. We want it to really function well as a teaching space. We want it to be aesthetic. We also know the impact that our buildings are having on our environments. We want to make sure that we're energy efficient, that we're good with water, with the habitat, with equity, social equity. And finally, some of our clients, go figure, care about time and money. So we want to make sure that we're building it cheaply to begin with, that it operates well over its lifespan, and that we deliver on time. So this idea of value is somehow achieving all of these different factors. How do we do that? Well, we're architects. We generate designs. We generate concepts. So here for this classroom, there's a bunch of decisions that we can make about how we're going to orient it, or slide these 2 bars apart, make the windows bigger or smaller, use different wall constructions, different overhang lengths, and things like that. So you generate a design, and you start to understand how's it perform. You might go to your mechanical consultant, get an engineering assessment of the energy. You might go to the contractor, understand how much it might cost to build, and then you kind of go in front of the client and you say, well, here's where we are. You kind of get a feel, are we meeting that value or not? And then you iterate. Design is iterative, so we go back and we start to generate more designs, try to understand this design space a little bit better. Ultimately, after we've run out of budget and the schedule has run out, we hopefully get to some place that satisfies the needs of the client, and we found a design that works for them, and we move on. Now, many of our clients are kind of 2-headed monsters, if you will, or we have complex groups of people that we need to work with, and trade-off and value isn't always the same to different people, so we need to somehow negotiate all of that. And I've kind of drawn this parallel coordinate plot with all these dashed lines to argue that we're really not doing this very well today, that even with all the technologies of BIM and analysis and things like that, it's very difficult to really systematically search the design space. We don't really know with certainty what our clients' values are often. We don't really do a very good job as an industry of really defining what all these experiential, economic, and ecological metrics are, and what are really the important metrics to design for. And we don't tend to be able to generate and systematically search through all of the alternatives that are possible. Just have a struggle really managing all of that information in the time given. And so I'll argue that Thornton Tomasetti accepted, the industry generally struggles to do this well, and that we almost invariably do not maximize value to the client. So the vision is something a little bit more like this. Construct a design space that systematically understands the target, the goals, the things that we're trying to achieve, systematically can look through all the different alternatives and be able to come to the client and say, this is how we're going to maximize your value. So that's the question. How do we formulate and make these decisions with confidence? And it's, to me, it's this concept of a design space. So what is a design space? It's a model. And we're familiar with BIM. BIM is a model of kind of one design. So let's step back a bit. A design space is a model of that entire exploration, all of those possible designs, all of the different performances of all of those designs on all these different criteria we care about. It's a model that includes an understanding of who the stakeholders are who we're trying to satisfy, and who the decisions makers are who actually know how to make that decision and have that power. So the designers who have the expertise to generate and analyze these alternatives. And it's the gatekeepers who know how to put constraints on the design to constrain that design space. And it's a process. It's a process of going through engaging these different stakeholders and formulating objectives, generating alternatives, analyzing the impacts, and then assessing the value. And so this is the kind of work that we're going to present now, is a couple of efforts in exploring how do we explore design spaces, how do we construct and explore design spaces. So the first sort of technological infrastructure that we're going to present has been built on top of really a Grasshopper Rhino, using things like the Honeybee and Ladybug platforms, and a lot of tools that Thornton Tomasetti here has provided that they explained. And we're going to just walk through one example of us using this Grasshopper infrastructure to build a design space. And so in this case, I'm going to just talk about an academic building that we're designing in Vancouver, and it was intended to meet the Passive House standard. So Passive House standard essentially wants you to really minimize the heating and cooling load in that building. It tends to create a fairly tight facade. Tendency is to want to try to make smaller and smaller windows to keep those heating and cooling loads down, which goes in a bit in conflict with an academic building where you start to envision great daylight and things like that. So that was really the problem that we had. So when we were approached by the design team and started to work with them, we understood, and you can sort of see the facades of the design that they had envisioned down here with these different openings, and they wanted to explore different panel types, different opening types in this structure. And these were the different kind of concepts that they had. And so we looked at the design and we said, well, that's interesting. To explore this completely, to explore every single one of those panel types and every single one of these openings would be a design space of about 10 to the 200. It's more sand, grains of sand than on the entire Earth, from what I understand. The smarter guys in my lab tell me. Vastly too big to explore. So you need to start to get into a process of understanding, you know, how do you constrain the world of all possibilities down to something that's actually modelable and manageable. And so for us, it really starts first with the kind of stakeholders and the designers and the decision makers, and really having a conversation to understand, what do we really need to look at, what's important to look at here. So we started to have conversations about grouping different panels into different parts of the facade, so that, you know, they didn't want to have something completely wacky. It needed to look somewhat rational. So that was able to get us down to about 288 million combinations. We then start doing some smaller design spaces. So in this case, we were just looking at window-to-wall ratio in different regions of the building to understand just the impact on energy. We knew Passive House was very important, so we decided to first focus in on the energy story and to understand what it would take to just make Passive House, and we'll look at daylight a little bit later. Then, once we understood and could constrain those window types more in terms of what was going to get us towards Passive House, we could then start to bring in the energy exploration. And with around 288 alternatives, we were then able to we were able to write a design of experience, which is a statistical view of that previous design space, to get us down to 288 designs that we could reasonably model on the technical infrastructure that we had at the time. And then ultimately, using the tool Design Explorer, we're able to filter that information and do the kind of trade-off and diving in that Rob described before. So just a little data about, does this make any difference? Does it actually help? And I get a lot of kind of resistance from people at Perkins & Will who really feel that the designer, has that intuition. They know kind of where the right solutions lie. And that goes a little bit in conflict, honestly, with the data and the research, which says, humans can kind of keep, in my case, 3 plus or minus 2 things in my mind at one time. It can be very hard, particularly in terms of building performance, where many things kind of conflict and interact, to really have the intuition about where the right design is. So we did a bit of a charrette. We picked the design teams. The first line up there is the project team's design when we engage them. And you can see that they were able to meet the cooling and heating loads. We're basically trying to drive those down, whereas we're trying to drive illumination up. We're trying to get more percentage of square footage to meet kind of the lead requirement for daylight, 300 to 3,000 lux. So the project team was able to get to this particular place. We then, wanted to make sure that this wasn't just a fluke, so we had a charrette in the office where we had 2 other design teams take the same project and work with it for a while to understand where they were able to get. And then we were able to come in and run our DSC, our design space construction process, and basically achieve all 3 goals fairly systematically and fairly quickly. And the metrics on the right give you a sense of kind of, what's happening. Currently, we're primarily a design firm. We're reliant on going out to our consultants for a lot of this information, which is great. We love our consultants. They're way smarter than we are in a lot of this stuff, but the timelines just don't allow us to wait for what's often 2 to 3 weeks to, have the meeting, give them all the information, have them run a few models, get back to us, interpret, translate. This has really allowed us to bring this expertise in-house to be able to do stuff really, really quickly and start to try to keep up with the design team. It continues to be a struggle, but we're able to get sort of better results faster for less fee. So that's kind of one design space. We've done this for many projects now, and we're continually engaging in research for how to improve this process. Part of this research has been to reach externally. So, for example, we're here in Atlanta working with a brilliant student out of Georgia Tech's Digital Building Lab to start to understand the geometric rules and methods for how we can start to generate design spaces, the generative aspect of it, more quickly, more robustly, to really gather designers' intent and translate them into these kinds of design exploration models. We're also really interested in how do we integrate this stuff into the creative design process. That last example I gave you was pretty analytical. The designers had really come up with the main scheme, and then we worked within that scheme. We're interested in, how do we get these design spaces up really early to start to inform the creative intuition and decision-making process. This is just an example from collaboration with the University of Washington, where we taught a studio with some of the studio professors there, and we introduced the technology early to try to drive their designs to try to meet Living Building Challenge in Seattle. And so with that, I'm going to introduce Benjamin Welly here, who's going to talk about another very significant aspect of research of really trying to make this stuff faster and more robust. And so Ben's going to talk about speed.
Good morning, everyone. I'm Benjamin Welly, as John introduced, and we have a long history together. He was my PhD advisor at Stanford, so we started kind of working this domain a long time ago. And like he said, we've been hearing this argument about, hey, the stuff you guys are doing is trying to automate the design process, and you're stifling our creative freedom. And our argument is no, we're really not. We did a survey of designers, and 40% of their time was spent in data management. all we're doing is allowing computers to do what they do well, manage data, thus freeing up that 40% to actually be creative and do what you do best, what a computer can't replace. So over the past 2 years, I have been, myself and a large group of people, have been developing a building analysis platform that was intended to be used internally by our designers during the earliest design stages, called SPEED, the Simulation Platform for Energy Efficient Design. And this is already an outdated name. We have daylighting, solar, we're going to be adding other metrics. I don't want to get rid of the name because the opportunities for puns and metaphors are just too much to give up. But just kind of want to talk to you about what it is, why we think it's going in the right direction, and start to get a feel from all of you what you think if we are going in the right direction. So what is SPEED? Well, it's a web-based, cloud-based Amazon Web Services knowledge management and reuse platform that does energy analysis, daylighting, solar radiation, sunlight analysis, shadow analysis, but more importantly, it's intended to be for our designers, their 24/7 virtual building consultant. And this is important because, like John said, often during the earliest design stages, from either pursuit to pre-design, programming, even early schematic, we do not have consultants. The baseline is no analysis, often, not always the case. And even if we do have consultants, the latency or the turnaround time from how quickly our design process moves forward at that stage, and how long it takes to turn around a request for some sort of analysis or information to make it back on time just doesn't happen on time. And so, why did we do it? Oh, and I have a very technical diagram that I decided not to show. We'll give a link at the end if you want to see it, but it's basically we have a web interface built in Angular. We have about 7 different servers. We use Open Studio Server to communicate with Amazon Web Services for parallelization of Radiance and Energy Plus, 7 languages, 75,000 lines of code. If you want to get the technical detail, there's a place to go do that. But again, it was clear to me a few years ago, we need a one-day turnaround from when the design question is asked to when you're able to do some model-based analysis, get some useful visualization back, and be able to understand what that's telling you and go back and help answer that design question, whether it's the project manager, design director, what have you. And that's really difficult to do, particularly if you're, 1, don't have a consultant, or 2, even if you have a consultant, that's very difficult. Tired of black boxes. Won't name names, we all know the black boxes. We wanted a fully transparent box, one that we could control, one that we could customize specific to our designers, and one that we could start to merge these silos of research, practice, and even business, to align what typically are 2 competing objectives. With, if it's rigorous enough to be research, it's probably not going to be applied in practice. It's too tough, and vice versa. John came up with practice-driven research, which we're still in the process of many people figuring out exactly what that means. My interpretation is that we develop an analysis platform, and we do not put anything in it unless we are all prepared to go defend it and our methodologies in front of a panel of our peers. And we will publish all our methodologies, how we do it. If people want to come and try to duplicate what we do, like Rob said, great. That just brings credibility to what we do, and it helps push the industry forward. We also, want to allow designers to generate quality energy and daylight models with just several hours of training. Part of the problem with a firm as large as ours in training people on a tool is that there's so many different tools, and it's hard to get everyone in the same place, same time, and everyone calls different inputs and outputs and energy metrics, different things. Really difficult to train. But if you develop the tool internally, you have the ability to streamline that. So one example I'll give is an MIT Student Center. This was an actual project. There was no one on the team that had high-performance building design experience. They wanted at least 3 massings for energy and daylight, and they wanted some visualizations to communicate to themselves and to the clients the best designs. We paid consultants to look up code defaults for an energy model. They use train trace, kind of standard bar charts, et cetera, no daylighting. Would charge us extra for other options, 2 to 4 weeks for a single run, 18K. Supposed to take the names out, but forget about that. So what they did is basically, while we had 2 different consultants on board, they brought in Energy Lab, in fact, Roy is sitting over there, who's on our team, to come in and, from research, from our lab, and we kind of, before kind of market ourselves as project by project service, come in and see what she could do. And she basically generated, over the course of 100 hours, 6 different options, found, EUI that was better than they were getting from their other consultants, had daylighting simulation, much clearer visualizations, and so that was, that was considered a really successful case study. So then I went in with speed, and we bring in all the prescriptive code requirements, nearest weather station, R values, loads, et cetera, automatically based on a few simple inputs. We allow for various parametric building footprint shapes, generate a large number of massing options, interactive visualizations, which is very key. And I'll show you some examples. We ran radians for every single run. It took me 15 minutes to set it up, 1,000 runs in 35 minutes. And we got, thankfully, a lower EUI. And so this is why we want to have this platform, because there's only so many of us internally that can do that middle column. We want to expose something to the masses. What can 80, 90% of our designers do in a reasonable time frame? So I'm going to show you a quick demo. I'm going to go very fast. So we log into the platform using Okta, our internal credentialing system, project portal to store your projects. Here you automatically have a list of the projects you have access to once you log in. You enter in a via Google API, look up the address of your site, and it automatically populates latitude, longitude. We have a weather service that looks up the closest DOE weather station, climate zone, energy code to bring in prescriptive values. You can put in your EUI benchmarks, targets, which are used later for visualizations, and then pick your building mode, which basically puts the tool in different modes to maintain the integrity of the statistical analysis at the end. Site context, adjacent buildings, all the visualizations are in Three.js. Right now we're in beta testing, and we're kind of getting feedback from designers. Do you want more buildings than that? Do you want sliders and not drop-downs? But here, the geometry page, everything's driven off the assumption the total square footage. You can play with number of floors, floor height, and these apply to all the different footprint shapes you want to look at. Here we have a list of footprint shapes that are pre-processed in terms of the parametrics, how you can drive the building form. Obviously, you can change the orientation. Down when we get to footprint dimensions, here's where we start to drive length and width. And we bring everything down to length and width. We auto-calculate thickness, perimeter depth, et cetera, et cetera. Anytime you automate something to be easy to use, you give up something in flexibility. This was our current option for a trade-off. So next, go to envelope page. You put the tool in building or facade mode. Do you want to define glazing by orientation or not? And you have a way to customize it by variables. So I can go in here, pick my window-wall ratio, number of windows on a south-facing facade right here, play with my window ratio, long skinny, short fat, select overhangs, fins, window construction, etc. I think in this example, I just put some fins on the west and the east. And then you can go and do that for each facade orientation. And before, there was a little checkbox under the south tab. If you check that, it applies what you select for south to everything. And that's important for the parametric study at the end. So here you can expand every view, a variety of display options. You can show the ground without the grid. You can display a Google map on top of it. And of course, the lat longe Google map looks up is probably not where your site is. So you can grab the building, drag it to wherever your site is, and it'll recenter the Google map. Display shadows. This is where we get into the real-time analysis to help you figure out what your design space should be. So here we use Three.js light sources to cast shadows on the exterior and on the interior of the building by hour. If you uncheck hour, you can run a sun range analysis, which will give you basically the aggregation of shadows over the course of whichever day you choose. Then we get to sunlight hour and solar radiation analysis. This uses radiance. And right now, you're going to see a radiance model generated from that 3JS code. Results are coming back from a 96-core machine on Amazon. So we generate all these images right here on 96 processors in parallel to have it come back in maybe 30 seconds. We actually use a new methodology to do this rather than how people traditionally do it. We're about to publish a paper on it to validate the method, but it goes in about 90% less time without losing much accuracy. And then here, just an example of solar radiation. Of course, you know, this is just kind of the dart in the dartboard. We want users to pick their color scale. Do you want high res, low res? You know, is this something you want to run really fast in 5 seconds, or do you want to put it in a presentation and present it to a client? So this is a solar analysis that's meant to help you figure out kind of what are the runs you actually want to do once you get to the longer energy plus and radiance runs. And then, of course, we have a 2D every time we generate a 3D. So I'm jumping right to the parametric study, skipped a bunch of pages. This is where you pick your design variables. What do you want to run your study on? And then you have a list of options. You can highlight one at a time, multiple, click over, drag it over. And as you do this, you can see the parametric study profile, little widget at the bottom, the total number of runs start to increase. This whole concept of creating a design space and the fact that you just add one more variable, 3 more options, it gets exponential, and all of a sudden you're at 2,000 when you're just at 100 is a new concept, you know, for designers. And so we have that there to let them know how many runs there are, and eventually we'll figure out estimating runtime, but I'll punt it on that for now. So here we're just kind of creating design space, and I think I do about 600 different options. It's interesting, we tell the beta testers, fire off 2,000 runs, we give everyone 500 cores for every project. No one does it. Everyone does 3 to 50. I don't know why. Part of it, the reason is it's new for them to do energy models. They don't really understand what's the value of doing a bunch of them. And that really gets to the statistical analysis, et cetera. So I'm just going to jump to some results. You get an email notification, the user, your project's ready. That project probably took about 2 hours to run. Variety of visualizations. Single run, pick your inputs. You can see static parameters. Here are the outputs we generate. Bottom 4 are from Radiance. Then we have our bar charts, annual, monthly, with interactive scenes below so you can understand what the design is. And if you pick EUI chart, remember that EUI target benchmark, you can see that relative to your design that you put in at the very beginning. Multiple run chart, same as the first one, but now you get up to 4 designs to compare. So we're slowly building up. The next couple charts, and am I able to pause that? No. I'll tell you right now, there's a PCP coming up, and I've always thought they're kind of boring. Even kind of the standard, with Design Explorer. And I always thought designers just aren't going to look at this. So I said, in a week, can we make it sexy? Can we make it more functional? This is what we came up with. You can tell me. We did a 3D PCP in 3JS. You select your inputs, you select your outputs. And you start to generate, as you all know by now, each line is a different design. And you have your brushing capabilities. We added a few new kind of brushing abilities that we didn't have before. But you can see here, it kind of works like everything else does. And we have a HUD pop-up. You hover over the line, it shows you the geometry, tells you some other information. If you have images at other places, it's hard to visually connect the line to the image. Here you get to hover. You can see it's pretty sensitive right now. You need to work on that. But then the 3D icons animated, we thought was pretty cool. Yeah. And to be honest, this will get a lot more people to look at and play with it. And at some point, they may actually be, hey, I see where this is useful. And so this is just a testament to why it's very powerful to have this kind of development and skill sets in-house. If someone came and asked us, this is what we want, we could probably do it. And we did that in 6 days. 3D scatter plot, same as the PCP, different representation. As you brush it, we ghost designs, same as you brush in a PCP. But what if we want to see that, of course, you hover over the point, You can get some more information about your geometry. What if you don't want to point? What if you want the building footprint? That's pretty cool. Target benchmark, EUI benchmark target as a plane. And then what if you want to go in and you have, you know, if you do 50 runs or 5,000, that'll get crowded. You need some way to customize how you see those shapes. So we have a scatter control. You go in there and you can rotate all the shapes any way you want. You can zoom in and out, make it small, large, customize it to what the data gave you back so you can get the type of visualizations you want. Have it face you. Turn that control off, and then we have preference shading. You have two objectives. You want to minimize, maximize. Some objectives are more important to others. Minimize cost, you know, minimize energy performance. Whatever it is, you can move that slider around. Haven't got to explaining to designers what a Pareto front is yet. Kind of avoiding that for now, but sensitivity analysis. This is where we do the statistical. We're no longer looking at all the runs at once. We're running an R script, do global sensitivity analysis, multivariate regression, to tell you which parameters are the most important. How do different input parameters interact with each other? What's the relationship? That's the value of doing a lot of runs, is you can start to apply these statistical methods rather than taking a few points randomly and try to tease some effect out. You can use math to do it, and it's much more reliable. So that's just a very fast view of kind of some of the highlights of the tool. And what I've heard over the past, month that designers have used it, well, that's great, but now we need to make it fit into our design process. And this is a very interesting topic to discuss. Because something's truly innovative, it probably shouldn't fit into an existing process. It's probably not that innovative in the first place. You would not take the inner workings. Apple would not take the inner workings of an iPhone X and put them in an iPhone 4 case. You had to optimize the case to optimize the overall product. But we don't move as fast as that industry, not really. For most people, what it means to fit it into our current design process is I have a Revit model, a SketchUp model, I have a Rhino model. I want to export and import into the tool. I get it. Those are tools you work in. Being able to run an energy model yourself is innovative, most definitely. Remember, the baseline here is generally no experience in energy modeling. But they don't understand that if you do that, you lose much of the innovation of the tool. And actually, the goal of the tool, if applied correctly, is to run it first, then go to Revit and SketchUp and Rhino and start from a better point. And why is that? Because building passive design, envelope optimization for energy daylighting is all about the ratios. What I mean by that, I mean, we have three of the coolest books about passive design written in the 60s, 70s, 80s. No building simulation, global climate change and sustainability were not like, keeping hot buzzwords. You had a very committed, talented group of designers that tried to understand the physics of energy and light flows, and heat flows, energy at the end of the day, and meld those with the art of design. And I remember in one book, there was like these great 5 pages that says, by climate, here are these different geometric ratios you kind of want to target. We're going beyond window wall ratio and aspect ratio. Compactness, form factor, shape factor, and there's a list of 15, 20 from literature. So I need to communicate this idea of why those 6 footprint shapes I showed before are still applicable to Perkins-Will projects in early design. Most people say, you don't do L's, you do T's. That won't work. Well, actually, it is useful. So I built this building in Design Builder, not super complex, but multiple footprint shapes. We have some building self-shading, et cetera, et cetera. Calculated the compactness index, shape coefficient, form factor, EUI 67.2. Went into speed, tried to match those building ratios, and for the most part did. EUI 63.9. Not the same. That model can tell you something about that building. And you can have even more extremes. You can have the most complex building in the world. It can be reduced to a bunch of ratios. And for the most part, if you can find a sweet spot with those ratios, you're at a better starting point. And I imagine a little plug-in in Revit, SketchUp, and Rhino, where you get the output from speed, you find your ideal kind of range of these, and you just have a little pop-up warning error if whatever you're doing in SketchUp, Revit, and Rhino goes outside of this range. very simple. That would be an incremental process, because the reality is we need to be, complement and supplement existing workflows in our industry, but push the envelope just enough that it gets people thinking about, hey, there's a lot of ways to design, and we should start thinking about it. So who made it? Obviously those of us in Energy Lab with John's support and the research board support, but a lot of other people, from developers for the front end to daylight simulation experts, Open Studio server experts. NREL has been great and given us a lot of tech support. Of course, we have some great people that work on the visualization side, but it's really a comprehensive effort, quite a few people. So what's next? Well, we want to develop a climate consultant. You go before you do the runs, using best practice, our database and AI. Fastest simulation run is when you don't have to. Calculation of daylight and glare probability, solar beam index, and other additional daylighting metrics. Allow the designers to block and stack those shapes, draw their own footprints. You use some of the parametrics, but you have clean models. Visualization of daylighting metrics on building geometry over time. Imagine point cloud data from radiance, and you can turn and walk through the building, look out, the luminance gets brighter. You have glare. You don't have to worry about the luminance being over 2,000 or daylight glare probably. Look out the window. How many is this glare? We feel we can put that virtual experience of being in a cave where you just load model and data on a 2D visualization. The baselines, circadian metrics, water savings, line of sight analysis, other metrics. And we want to get Grasshopper in there to start to merge the best of DSC, and which allows you far more flexibility in parametrics and the functionality of speed. And with that, I guess we'll open it up to questions. We do have a wiki where, several different websites, more information on science-based construction on DSC. We can go there. We're starting to create a wiki where we're starting to document what we're doing with the platform, assumptions, have designers go ask their questions, put known issues, wish lists of what you'd like to develop. So invite you to take a look and give your feedback.